What's up, everyone? Welcome to Desmond's Garage. I'm Desmond. Today we have kind of a big project. We're going to build a Tiki tube amp. What's a Tiki tube amp? I'm sure you're asking. It is a tube hi-fi stereo amplifier built into a carved Tiki head. What's going on there? So these vacuum tubes, vintage technology for basically everything. They're the precursor transistors, used to be everywhere, have been superseded largely by transistors, except for high-end audio. And you see them a lot in guitar and bass amps and in hi-fi stereos. So we use these to make the circuit to amplify the sound between your record player, your CD player, whatever, and the speakers. And you can buy them around the internet or wherever else you buy high-end audio, but you never see them in fun enclosures. They're usually sleek metal boxes, whatever. So I thought, why not put them in something fun? And what could be more fun than Tiki? I don't know. So what we're going to do is take a log, carve a Tiki face into it, and then build the circuitry inside. This one I've obviously already done. We're going to build a new one today. And how does this open up? So you can see in this model, there's a bunch of electronics componentry inside. So with this, we sliced the log in half, hollowed it out to fit the transformers and the circuitry. And the back has inputs, speaker outputs, our power switch, and of course, our power input. And it's worked pretty well. We're going to build a new one today out of this log. So this is going to be probably a series of videos because they take a little while. These things take a while to make. There's carving. There's sort of like internal processing to get everything ready to receive the electronics. And there's actually mounting the electronics. There's an interplay between how do we carve the face and how do we make it able to support these tubes and the sockets that they mount in. We have a volume control here. So it's kind of like a lot of back and forth and getting everything to fit together. So as I said, this will probably be a series of videos. We'll see how far we get in this one. But this is sort of where we're going. And this is how it starts. So how's this going to work? The new one is going to look a little different. Each of these has a unique face, but there's certain kind of common things we have to have in mind. The new one will also have the same configuration of tubes. We have 4 power tubes here. These are preamp tubes. This is another preamp tube. And then there's going to be an additional one for a tube rectifier. So we're going to have 6, 7, 8 tubes to work with. And slightly different design, whatever's fun. And so we're going to look at how we go from turning this log, I believe it's an elm log, a slippery elm log, into a carved Tiki tube amp. So where do we begin? We begin, of course, with a piece of wood. This was claimed from a local arborist. They cut down a tree. I live in Los Angeles, and I got a bunch of wood from them. Probably too much, but not all wood works for these amps. Different kinds of wood work fine, but they have to be a certain size. You have to be able to fit the electronics in them and also the tubes in the front. So you can't have too small a log because then there's not room for everything. Too large a log? I don't know what the limit is yet. I suppose I'll find out one day. So you need to have something that's about 12 inches in diameter. This one is 11 and a half, 10, so close enough. It's about 14 3/4 high. So it's this is a big log. It's fairly green. Ideally, these dry out for several years, but I don't have that luxury. I don't want to wait several years to make one of these. So we work with it. That will factor into our construction of this. So the last one you saw split open. I would just kind of carve it down the center with my bandsaw and fit everything inside. That presented some problems because the wood would warp away from the cut since it was no longer bound together. Even with the insides hollowed out, there was still enough pressure with the wood as it dried even further that it would move slightly. And with this one, we're going to do something a little different where we hollow out the ends and make kind of a tube or a tube. And we're a cylinder, really. So the face will be carved into one side. There'll be an open cylinder, which means the walls, the outside of the log, can expand and contract as much as they want, and it won't affect how it's put together because it's not actually separated. That'll also make construction a little easier of the electronics. We don't have to deal with as many wiring connectors that have to split apart as we open it up. Everything can just be wired in. And I think it'll make it overall a lot better. But we're going to find out as we go through this. As you know, we always run into issues along the way that we deal with and keep going. But I'm excited to try out this new construction technique. It also means if I'm not having to saw it through, I don't have to worry about the limits of my bandsaw. My bandsaw takes up to about 11 3/4, so this might actually fit in there. It's kind of pushing it. Now I don't have to worry about it. I can use a larger log if I want to. So what do we do first? This one has had the bark removed. That's kind of step one. Take the bark off so you know what you're working with the wood itself. So once the bark is removed, the first thing we want to do is carve the face. We need to have the face carved so we know how deeply we've relieved into the wood before we hollow out the center. And I don't know until I've carved it how much I need to carve out of it to make the shadows, to make the face, to make whatever other details I want. And so I can't know in advance if this outer wall should be an inch thick or 3/4 an inch or whatever for mounting the components inside. So step one, we are going to draw a face on it. And then step two, carve out the face. The face will include the features and then the locations of all the tubes. So that's the other thing, is as we're planning out the face, we need to know where the tubes are going to fit. We need to know where the volume control is going to be. That's a little potentiometer that sticks through. You got to kind of plan all this stuff out in advance, make sure it fits, and also understand that the components fit through into the inside and have wires coming out from the inside. So you need to be able to drill a hole clear through it. You can't just sit the socket in. There needs to be a tube going from the socket, in addition to the tube, like another sort of hollow tube through the wood for the wires to get inside for the rest of the electronics. So step one, I forget what step we're at. I think this is step one. We already had step 0, which was remove the bark. Step one, we need to draw the face, and the next step will be carving the face. And then we can look at hollowing it out, getting electronics in. There's other stuff along the way, like staining and so forth, and a bunch of finishing that we will get to. But now that we have our log, this is probably 40 pounds, 50 pounds. Anyway, we need to carve something into it. So we're going to get this set up on a table where I can walk around it, figure out how I want it to look. And we will go from there. At last, time has come to turn it on for the first time. Checked all my wiring. I've double checked all my wiring. Still a little nervous because I'm always nervous. No, you're always nervous when you turn it on the first time. But we'll do this slowly. We have it hooked up to my 2-amp testing rig. We'll power it on with the Variac slowly. We have speakers running into my dummy load here. And we have leads going into our voltmeters. So as we turn up the master voltage on the power that's going into this, we should see the volts start to climb. We're testing the power tube plate voltage and the voltage going to the preamp tube plate. So we should see about 340 to 350 volts on the power tubes. And what do we have here? Maybe 280 volts on the preamps. It looks like the power tubes will be maybe around 310 volts. Let's see what we've got. There'll be a jump because as we're turning this on slowly, none of the tubes will conduct until their filaments get hot enough. The filament voltage is rising in proportion with this. So until that gets anywhere, nothing's going to happen. So I don't expect to see anything at first. But what might happen at first is that it blows up. And then we'll deal with it. So with that, turn this on. We've got 132 volts going to it, so we'll turn this down. 3 volts, basically nothing. Cowabunga. That's better. Turning it on slowly like this gradually increases the voltage on the capacitors, filter caps, which helps them sort of finish forming themselves. We should start to see some voltages soon. Oh, something's happening. Something's happening. You can see the filaments have gotten hot enough now. Okay, I know what this is. Alarming sound catches me off guard, but the negative feedback coming off the output transformers is essentially out of phase. So instead of giving us negative feedback, it's giving us positive feedback and that weird sound. So that means I need to swap the leads on my push-pull output tubes. That will reverse the phase, the signal going to the transformer, and the feedback coming off of it will be correctly out of phase. So we're going to cut it here, and I'll fix this and be right back. We're back. Swap my wires. Could hear the issue on both the left and the right channel. So it's been fixed. So let's try it again. On there. Actually, before I do that, turn on the Variac. 7 volts. Amps on. Start turning it up. See that voltage jump sometime around now. There we go. 120. Volume's all the way down. 322, 267, 270. Seems right. It's daylight out, so we can't really see. Can't really see the filaments going in these. I can because I'm up close. But there's one way to test this for sure, and that is to run some sound through it. So I have this hooked up to my laptop, which is back here. And let's see if we hear anything. Yeah. Music. Sweet. I have a tradition of playing reggae music when I first turn these on. Happened by accident at first, and now superstition. Great. Well, it's working. I don't know how good it sounds exactly because these speakers are just kind of tinny to see if it works at all. But here we are. Voltages are all on spec. I'm happy. So let's see. What's next? I have a few other things to check. A couple other construction things or wiring things to sort out. And then go. But another amp alive. Got you zoomed in here on the testing rig so you can see more of the precise details. So starting down there, this is the stats on the power coming from the wall. So the wall is showing us 123 volts. The whole system is drawing 150 watts. That's all the circuitry in addition to the amplifier. The amp is plugged in here to the output of my Variac, which is outputting 119, 120 volts. Fluctuating a bit with this and probably also the current draw. The current draw we can see up here on this little ammeter. It's looking like 1.3 amps times 120 volts, about 150 watts. And over on the left, we have our high voltage meters. So 327 is the voltage on the plates of the power tubes. 274 is going to all of our preamps. And then this one down here is on the plate of the first preamp stage. This is a 12AU7 ECC82 tube, and that's right on the plate. This tube has quite a bit of current draw, so there's a bigger voltage drop across it than there would be across, say, a 12AX7, or even these 6SL7s, which are the other preamp tubes, which are being fed by this 274 volts. So this is also not on the plates of the 6SL7s themselves. That's the B plus power supply. So I made a previous video about this thing, but it's pretty handy. I'm not using a lot of this stuff. This is where the speakers go in to feed either dummy load resistors or, in our case right now, some simple speakers. And yeah, super helpful to have these readouts, and you can see at a glance these voltages are fairly stable. I don't have to go check back and forth with my little pocket multimeter. It's really convenient having these just kind of wired in. Bringing you up top, you can see our circuitry and where I have the leads coming in. The red is the A voltage on the power supply going to the power tubes. The blue is B plus going to the preamps. And this green one is headed to the plate of the left channel of the first preamp stage. Gory details in the back. Cool. Got the big guy flipped on his head so you can see what's inside at the bottom. It's a lot of the power stuff. We got our power transformer here. Behind it you can see the two output transformers. These are mounted at right angles to each other to prevent electromagnetic interference. Got a little junction board here with the wires and the transformer. For the low voltage filament, this is a 5-volt filament for the rectifier tube. High voltage wires are down there. And these things here, these wires here going off to our rectifier tube, our 5-volt heater, and then the high voltage AC that's going to get rectified. And the rest of this is the rectifier for the heater filaments on the other tubes. So this takes the 6.3 AC volts and changes it to about 6.5 DC volts. And we've got our smoothing capacitor there. And you can also see where some of the power tubes are mounted here and the inner walls. And oh yeah, this section here is part of our power supply filtering. We have a couple dropping resistors and then some filter caps for the power tubes. The filtering for the preamp happens down there in the preamp board, which you can sort of see. That silver lining is the underside of the board, and all of our components are on top of it. So pretty clean little mount up here. Plenty of room for air to get sucked in by the heat from these transformers, and by convection it pulls air in and sends it up to the top, which of course is on the bottom right now, and out the head of the amp, keeping everything cool. Got our amp all plugged in here and hooked up. See how it sounds. With that, we have built a Tiki tube amp. I've named this Isaac, because that's what it wanted to be named. And I think it looks great. I'm really happy with this. I think this is a really solid construction with our kind of cylinder style here and the hollowed out core. Gives us great airflow with the components. Things were much easier to mount up than other iterations I've tried. We have a nice smooth outside, unbroken by any seams for all of our carving, our tubes, hardware with our volume knob and power switch, power socket and fuse, and speaker outs and RCA ins. This was a lot of fun to make. I hope you enjoyed this video. I make these for a living, so if you're interested in ordering this one or another custom one, please get in touch. There'll be a link in the notes. And I would love to do some more videos going into detail about some of the individual components that I did here. This was more of an overview of kind of the start to finish process, but there's a lot of little things along the way that take time and really take energy and focus to really dial it in quite well. But it's been a lot of fun making this, been a lot of fun sharing with you. I hope you had fun with it. If you have any questions, drop me a note in the comments or whatever. So until next time, stay groovy.